Pharmaceutical Processing, in conjunction with INTERPHEX, presents INTERPHEX Live.
Good morning, New York. All right, we're up. That's what I like to see. Okay, so welcome to INTERPHEX Live, second day. Hopefully we'll survive again, so we're ready to go. First up is advanced and highly adaptive automation technology integrated with Industry 4.0. Our speakers are Steve Madruga from Kinetics. He's the technical program manager there. And Yvonne Duckworth from CRB. She is the lead automation engineer. Did I get that right? Good. That's a good start. Okay. So, one of the things that we picked up on in several of our programs already is the use of the terminology Industry 4.0. So we're going to level up on that, make sure everybody's on the same page, and then we'll dive into the adaptive technologies. So, Yvonne, maybe what we got to do is, what is it? Turn it on? Now try it.
Okay. So, Industry 4.0, what is it? We've all heard about the first industrial revolution, the second industrial revolution. Those were based on steam power, oil power, combustion engines. We had the third industrial revolution, which came about not all that long ago, which was basically computerization, digitization, PLCs, controllers, you know, that was all part of the third industrial revolution. So Industry 4.0 is actually the fourth industrial revolution, and it's centered on automation. There's actually 9 different, so if you Google what's Industry 4.0, one of the graphics that you may wind up seeing is a ring of 9 different things in a circle. And each of those are a component of Industry 4.0. And we'll be talking in depth in some of them. Some of those concepts are making their way into the pharmaceutical industry more quickly than others. But some of those concepts include robotics, artificial intelligence, augmented reality, additive manufacturing, which is another word for 3D printing, the use of the cloud, cybersecurity, industrial Internet of Things, horizontal and vertical system integration, and simulation. So that's really what makes up Industry 4.0. It was a term that was coined in Germany, not industry specific, so it spans across any industry, and it really represents a paradigm shift from centralizing to decentralizing with flexible manufacturing.
So why don't we get, seeing that that's more of a why don't we get into Pharma 4.0 and how that all ties together?
So Pharma 4.0, a term that you may have heard, so ISPE started a special interest group back in 2017 called Pharma 4.0. And basically the intent of that is to take these Industry 4.0 concepts and segue them into the pharmaceutical industry. And again, like I said, some of them are easier to incorporate into pharma, others may take a little more time, but the goal of that special interest group is to have that holistic transition. I actually just got invited last month to be part of that special interest group for Pharma 4.0, so I'm pretty excited about that and to see where that's going to take us.
So do you think we're ready, or?
I do, and I think the really exciting part of this is that there is a number of Industry 4.0 things that we are doing already, and I kind of realized that about a year and a half ago, I guess, on several of the projects that I was working on at my company, CRB. We're a design engineering, consulting engineering company, and I started looking around and thinking, wow, we're doing this already. We're doing this on a number of different projects, and it was just really exciting that, you know, we're making that headway in the industry with this exciting stuff.
All right, so I think that's the background against which we want to work. So we'll get into the more specific nature of what we're going to be talking about, and that is adaptive automation. And where we're going to start off, because of the interest in single use, obviously, in our industry at the present time, is one of the things we thought was the most intuitive to start off would be single use instrumentation and how more prevalent that is now in our in the biotech and also in the small molecule area, and the use of single use instruments and the benefits. So we're going to go from there and see where it fits into that scope, you know, especially like, I guess, like the clean in place and stuff like that as well. So let's talk about that aspect now.
Yeah, so single use is, a big term everybody's using. You're seeing it with equipment, we're seeing it with instrumentation. There's a number of, and again, I'm coming at it from the design side of things, so I see it from, implementing it properly and making sure you consider the right things when you are implementing the design from an instrumentation and automation perspective. So imagine you want to have the ability you have a cart and you have a peri pump on a cart and you have a single use flow meter and temperature transmitter on there. So you pull your cart up, you have to connect it. So on this cart you have your pump, you have your sensor for your flow meter and your sensor for your temperature. Those have to get connected back to a panel or to their specific transmitter. So one thing that you need to think about is who's providing the sensor. A lot of times our clients provide the sensor because they're going to be continuing to be buying that sensor. So we'll just spec out the transmitter, so you got to make sure the transmitter matches up with the sensor. Another big thing you have to think about is the cords that go between any cabling. I don't know if you've seen, any like nightmare pictures of a single-use application where it's just like a sea of spaghetti. There's tubing and there's cords all over the place. So you don't want that. So you really have to think about how do you manage that. So in this particular example that I worked on for a project, like I said, we had our cart. We had our two transmitters were not IP65 rated, so they needed to go in their own panel. So we designed a special panel to put the transmitters in, but the single-use sensors were on the cart. So we needed a cable to go from the sensor to the panel. How long do you want that to be? You don't want it to be too long, you don't want it to be too short. When you disconnect it, you don't want a tripping hazard. So there's a lot of bits and pieces that really need to be thought about to go into making this effective and work for the operators when you're trying to set this up. Another thing is the connections on both sides. There's some of the connectors have male ends, some have female ends, some are at right angles, some are straight, some need to be hardwired, some screw on. So there's a number of different things that all have to be thought about when you're doing that. And then the other key aspect of single use is the plugging and unplugging. You have a set, let's take it for example, a Profibus segment. Profibus doesn't like to be disconnected. So you have a number of different things that are all on a segment, and you say, well, I have a couple panels, I have a weight transmitter, and then I have a pump. Well, that weight transmitter, I need it to go over here, so I need to be able to disconnect it and bring it somewhere else to weigh something else. So you try pulling that out of the segment, and the control system is not going to be happy. And the control system shouldn't be happy. It should be telling you, hey, there's a problem. But there is a way that you can isolate. There's a thing called a repeater that you would add into that segment to make sure that when you disconnect that device, it doesn't mess up your communication. So the point to that is there's ways around this. You just have to think through what are the best ways in order from an engineering side of it to make your segment or make your devices that you need to be able to be disconnected and not cause havoc with your control system or lose data.
So when we do this, just to be clear, so if I'm either going to clean or I have to reconfigure for a process, I have to unplug this stuff. How much time does that add? I mean, that's my point. I mean, if you have to plug and unplug, if you don't take the precautions, it's obviously going to be a protracted event as opposed to the repeater. And maybe do you just clarify that for me? Or?
Yeah, so this repeater, what it does, it basically takes that one particular device and isolates it from the rest of the segment. So it's still part of that segment, but it's isolated from the rest of it, so you could disconnect it and then do something with that and then bring it back and reconnect it, and it does not affect the rest of the segment. So it's just a piece of hardware that you need to add into your hardware design, basically.
Okay. Do you have something to add to that, Steve? Or?
This is on.
There you go.
Sorry. Sorry. So my expertise is more on the construction and installation side. So I mean, obviously, it's a trend to to maximize the space in the room. Just like we're on the AR or VR side, we're doing everything we can as far as leveraging technology. So, basically my understanding of it, it's basically kind of creating a supplemental signal that allows you to disconnect that one device, you're not interrupting the signal back to the controller and then being able to plug it right back in.
Okay.
And not skipping a beat. So.
Okay. Well, apparently, I guess if we get into this whole thing of wireless design, and let me ask you. So we'll talk. What wireless has become popular? I heard that from both. The bottom line is, what do you take into account when you do a systems design? How do you account for that? All right. So the idea being wireless. I mean, there's got to be. Where do you start, right? Okay.
Yeah. So in order to put in a wireless system, it takes a lot of work and a lot of thinking up front, and a lot has to go into the design to make this effective. The first thing that we always need to make sure we do is to do an initial field survey. So let's say you're working on a brand new facility and you want to wait at least until the walls are up and the doors. You may not have all your process equipment in yet, but you need to do an initial survey just to kind of get a feel for what your signal strengths are, where you want to put your receivers. So that's an important step, but the really important step is once the equipment and everything else is in the room that's going to be in the room, you need to come back and do a final survey. Then that's really where you may say, oh, well, we need another receiver here or we need a repeater here, just to make sure, because the problem is we have stainless steel tanks, and stainless steel tanks are going to interfere with your wireless communication. There's piping, there's the modular walls, they are made of metal, ductwork, that all plays a part in this. So that all has to be in place, a final installation of it before you can really turn over your wireless system to say it's going to be working properly. Another thing is VFDs. So you may have a couple pumps that have a VFD. If you try and make your wireless infrastructure too close to where you have a VFD, where there's a lot of interference, 4,000 hertz of noise, you could have a problem. So that all has to get thought about and carefully positioned when you're setting up your wireless infrastructure. The other thing is receivers. So I remember thinking, well, if you just add some extra receivers in, but if you put too many receivers in and they're too close together, you get distortion. If they're too far apart, then you don't have enough signal strength. So it's a really tricky type of thing. And I guess wireless, just from what I've seen with the pharmaceutical industry, I think it's becoming more of a thing. But from a monitoring side of things, I don't think necessarily control yet. I think a lot of people aren't quite comfortable with using wireless from a control side of things. But monitoring, like environmental monitoring systems, I've seen a number of applications and installations and designs that I've worked on that are based on a wireless system.
So, I mean, basically, when you think about Pharma 4.0 and Industry 4.0, these are the trends that we're seeing in the engineering and the design aspects. Is this use of wireless?
Yeah, I mean, I'll jump in there. So we've noticed as far, even on the construction side, going into an existing facility or even a greenfield facility where we're building a new facility, one of the first things they're putting up is wireless, because not only is it the industry as far as the equipment going in wireless, but also a lot of technology on the construction side to build those facilities are going wireless and tying into the wireless system. So I don't think there's been an existing facility we've gone into yet that hasn't had a good wireless network throughout the clean space, dirty space, wherever it may be. It's just, like Yvonne says, when you start getting into the controls aspect, if you're using it to log in with any type of your laptop or whatnot, you can absorb a little interrupt in the signal or something like that. But when you're dealing with controls, I'm sure Yvonne will kind of agree that you can't afford that hiccup. So
that I heard this right. I mean, pretty much, if you're building a new facility, it's greenfield. Let's assume the answer to that is your wireless infrastructure. You really can't finalize that till the facility is done. So maybe I'm asking, how do you do the cart before the horse? I mean, can you looking at a floor plan or a CAD design, you can say, okay, this is what we're going to need? I mean, you got a pretty good idea, or am I off base there? Either way.
Yeah, I mean, as far as the wireless design, you're going to have your initial, right? You're going to place your boxes pretty much in a specific range as far as coverage goes. You know that you're going to, if it's going to be an aluminum wall system, you know it's going to block signal, so you might need another one in the hallway. And then I think what Yvonne was alluding to is once your final installation's done, you have to kind of go through and do a survey of the existing, of what you put in, and see if you have to add anything, move anything, because it's not an exact science. You can't predict exactly how the Wi-Fi signal is going to bounce off a stainless steel pipe or an insulated pipe or a tank or a bioreactor that has 200 lines in it and fits in a 4 foot by 8 foot square, right? And you're the operator sitting on the other side of that between a stainless steel vessel and a big skid. You just don't know how it's going to react until all that stuff's in there.
So, and proactively, what do you suggest? I mean, I'm also hearing that over-designing doesn't work either, because then you get into the other side.
Right. So I think that's just where it's important to, look at it at the beginning and then go back at the end and know that you're going to have to make some adjustments.
Okay. So I think one of the things that what we've been hearing is a lot of the reason we do wireless enabling is not only to be able to track, control, or monitor, but it's also we want to do troubleshooting. We want to, we got to manage the process. And what we heard from many of our speakers is that they want, AR, VR, AI. I mean, bottom line is this. I think in the context of our discussion here, why don't we talk about the differences between AR and VR? I mean, I got a sense the other day we were kind of mixing them up, and I want to take this as the opportunity to straighten that out.
Sure. So basically the difference between the two is, so virtual reality is when you're actually created, almost like a video game, you've created this artificial world that you try to immerse the person or the operator in. You do that by putting on basically a headset that's projecting what that virtual reality is. Depending upon the style you get, it sometimes takes anywhere from 3 to 5 minutes for the human eye to adjust to that virtual reality, because the frame rate of those lenses, the human eye can only absorb so many frame rates per second. So you have to be real careful on what you get. Once you have that and you're in that, you can virtually walk around the space, but you're not physically moving. Usually you're standing. Some people like to sit down. Sometimes you have a hand controllers that allows you to jump from location to location, but you can virtually look around the entire facility without ever leaving your office or leaving the chair. Augmented reality is a little bit different. It works along with whether it's I know HP has basically a virtual glass. You have Google Glass, you have HoloLens. There's different, but basically you put on these glasses and projected on the inside lens of those glasses is the virtual reality, whether it's a new skid you're putting in, the new facility you're building, or whatever it may be, and you're seeing through that image and you're able to walk through it. So for instance, we had this room here, we could put in a piece of equipment and you can virtually walk around that piece of equipment, look underneath it, look on top of it. It's life size. Just like as in VR is one-to-one life size, but it gives you a little bit more aspects, more interaction as far as the augmented reality, because it's a little bit easier to absorb too, because you can walk around the space, you can see what it's going to look like in that space.
Right, because it uses your real world as your background, as opposed to virtual reality is completely computer generated, but the augmented reality is a graphical representation over reality.
So what are the benefits of AR from a client's perspective? I come to you guys and talk to me. What advantages do I get out of this?
So, I guess I'll start first.
You can take turns. Don't fight.
Sorry.
Okay.
So this is one of the really cool things that we've worked with Steve's company. They are a piping contractor company that we've worked with in the past, and this one particular project we worked on in the past, their company went in and did a laser scan of this existing area, and they were able to pull that laser scan image and use it as the background for their model that they were modeling the new skid and new equipment in. And it was just really cool because the quality of the laser scan gives you this crystal clear image of what your existing background is. And it's just amazing to see that because it allows you then to have that as your background, model your new piping over that. You can go in, you can measure clearances, you can see what is there. Maybe there's a disconnect that you forgot about, and all of a sudden you see it in your image, and you say, oh, now I got to move this disconnect because I don't have enough clearance from that. So it allows you to have an advantage of being able to make any modifications that you need to make everything fit properly.
Some of the other benefits to not only on the design side, right? For instance, a particular project that we just finished up with CRB is looking at bringing in the client as far as the safety. We brought in the safety department. They looked at the clearances. They looked at, they looked for trip hazards. They looked for anything that would, obviously, number one, want to make sure that their operators are safe. And then two, looking at what the design is going to look like. So you can imagine you have this gray space, might be a 4-foot, 5-foot wide corridor, and you walk down, you have existing pipes lined up and down it, but then you can actually virtually walk through it and see where all your tie-ins are going to be, where you're going to add some multi-port block body valves. You can see where you're going to add the new pump. And you can get that from a traditional Navisworks model. You can get that from virtual reality, but nothing beats walking through the actual space. So some of the other benefits might be if you're doing a retrofit on the top of a vessel, right? Or we've done modifications to bioreactors and looking at how filter pulls are, so that way a client can actually simulate what it's going to be like to pull a filter, take it to the wash gown, push the cart through a virtual space of what it's going to be when it's done, and ask the operator, the end user, hey, do you see any problems with this? Oh, I might like this bumped over a few inches. And we simulated column pulls as far as pulling a tank from one side of the room through a small tight pinch point all around the other side. So the client gets to obviously get his input in the design versus at the end, if you weren't to do that type of process and you miss something in the design side by doing traditional 2D plans and drawing reviews, the end cost to the client is going to be a lot higher.
Right, let me ask you a question before we go too much. So how does that, so you're saying laser scanner, audio, augmented reality. So how do I start that? So I'm saying, let's back up and say, okay, that sounds great, but how do I do that? Can we go through that?
Sure. Well, it depends if you're doing an existing facility or obviously a greenfield. But I'll give you an example of some of of a project. So
this is a greenfield?
This is actually an existing facility. So
okay.
An existing facility, we go in, and the first thing you want to do is establish some type of marker system. And some of your facilities might have it, some don't. It looks like a little checkerboard target, but you place those kind of along the corridors. You make it kind of a permanent structure, so that way if you're going to be maintaining a model and maintaining this, you can constantly update it and you reference that same control point. So you go in, you laser scan your existing facility. You either keep that laser scan and use that as your background, or you can take that and have it converted into a 3D model that you can maintain and update. Then obviously you're going to design whatever new systems you would like, and then you can load that in as well. So I guess the steps would be obviously laser scanning your existing facility, converting that to a model, or updating an existing model. You might have a model that's 10 years old, but your facilities group hasn't maintained it for the past 10 years, so you need to update it. Then obviously take that updated 3D model, and that's what you're going to use in your AR view or your VR view as far as your background is concerned.
The reason I asked the question, Yvonne, one of the things that Annette Kruger talked about yesterday, and that was capitalization of existing facilities, people greenfield. It was really a capitalization versus, do I start it over again? So I think in a lot of cases, this would be of great benefit to somebody who's thinking, hey, I could get pennies on a buck for this facility rather than go greenfield someplace. That's the backdrop. So to me, the question is, we don't, if you're going in and you're looking at this existing facility and you want to bring it up to date, you want to do that. I mean, the background probably would be kind of hinky, I don't know what they got. It could be, it could be disparate. And so I got this building. I mean, we could just walk into this and create it, or do you need some sort of do you need data that, for example, the old CAD design or even the old paper design? How do we start?
No, you can walk into any building. It could be 300 years old.
Right.
No CAD backgrounds are needed whatsoever. So the way a laser scan works kind of looks like a square Bose speaker almost. It sits in every location you set it up at. It takes 3 to 5 minutes to do a scan. It'll take 5 million measurements in that 3 to 5 minutes. So, and it'll reach up to 270 feet. So what it does is it takes that data, pulls it down, then you move it to the next location. You usually want to move that scan about every 5 feet. So you can imagine, 3 to 5 minutes, moving it every 5 feet. You can kind of calculate the time. You can do a decent amount of square footage in a given day. You do about 120 to 150 scans in a given day. You bring that back, that gets plugged into a computer, and that computer takes those 150, 130 images and basically plays a big jigsaw puzzle. It
Right.
stitches them together, it figures out where they play together, and those targets that you put on the wall ahead of time kind of give it a reference point. Because at one scan you might see target number 1, and then the second and the third scan you see target number 1. Well, it knows that it matches those up. And that pattern, the computer program is designed to look for that pattern of that target. So at the end of the day, you end up with a virtual, what we call a point cloud. It's basically those little dots, those 5 million measurements that it takes. It puts a little dot in the cloud, and literally you end up with an image of dots. Well, you get enough of those pixels, you get an image. And then on top of that, as it's spinning, it's taking those measurements. It takes those measurements much like a piece of graph paper does. Okay, so you program in how big do you want that graph paper. Well, when it finishes taking those measurements, it spins around and takes a 3D picture. So a lot of people have, you've got an iPhone or a 3D camera, everybody's kind of done that little panoramic picture. It takes those digital pictures and those pixels and actually stitches it in between those little pixels of the laser scan points of the measurements. So then you basically come up with a photorealistic scan, and which is kind of what Yvonne experienced. So that's kind of like the technical back. So to answer your question, you don't need anything except the scanner and the software to run it.
So so then that comes up to, all right, let's talk about how we're going to use that, right? So
I think I just wanted to say the one really cool thing I think that I just wanted to bring out. I mean, I know we're talking about a lot of cool technology here, but I think the good thing is that there's a lot of value to be added in implementing this, and the bottom line is we're already designing in 3D, and to make this happen, it's a pretty low cost to give you this capability to be able to go in and to have the either a virtual reality experience or an augmented reality experience, and I think it really enhances the whole design process and for a pretty low cost. So I think that's an important thing to consider, because there, like I said, the Industry 4.0 again has a lot of different aspects to it. Some are more expensive than others. Some may add more value to your particular company more so than others. So that's definitely something you need to consider when you're thinking about moving towards Industry 4.0.
Yeah, I think one of the things I want to get back to, though, and one of the things, at least as a process guy, that I thought was pretty cool was the smart glasses, especially if I'm going to go out and I'm going to troubleshoot something, or, because we always hear it, either fly the guy out, or where's the expert, where the data. I mean, with a smart glass, to me, smart glasses seems to be the best answer to this, so maybe can we walk through something like that?
Yeah. So I think smart glasses are definitely making their way in the pharmaceutical industry from different applications that I've seen at this point so far. There's the one cool thing is the see what I see technology. So like you said, you could have your main technical lead somewhere in a remote office and have your key person standing there looking at a problem and have the glasses on, and they could be talking, and that person will say, turn your head to the right a little bit. Okay, let me see what you have there. Open this valve, do this. So there's a lot of benefit in that from troubleshooting purposes, and even too in having clean rooms and not having to have everybody go into and gown up in a clean room. So I think there is a lot of benefit there. Also seeing a lot with for training purposes, which I think that is good. Warehousing inventory is also another application that we're seeing that too. And then as well, the augmented reality that I know that you guys do too with the smart glasses.
Yeah, so not only with the augmented reality as far as using it on a construction basis, kind of like Yvonne said, there's a lot of more applications to it. You can actually program them to read your sensors. You can actually program them to run your equipment. So I work for Kinetics. We're a global process contractor, but just like working with CRB, where the design assist model is becoming more and more on the contracting side, right? You bring the specialized engineers like CRB in, they're working on the PNIDs. They also have, and then you bring the specialized contractor in to help bring that design, add constructability. So that's why we're getting involved in it as well. But overseas in different industries, semiconductor industry, they're actually programming these glasses to run and pull up data sheets, so they can walk up to for instance, they can walk up to a chem cabinet, full PPE, not have to open it to look at and get status of where they're at with that piece of equipment. And they can, and like Yvonne said, if they have an issue, you can dial into those glasses at any given time. So even the operator, the person wearing the glasses, doesn't need to be the expert. Really, the expert can be remote. So you can actually put on the glasses, turn them on, person can see it from 3,000 miles away. I can load a model from that aspect. I can load a cut sheet. I can load a submittal. I can give you status from the control room, or even show you what the control room's seeing as far as on the control side. So there's a lot of benefits, and you can. It's making its way in there because obviously we're all trying to save time. At the end of the day, we're trying to save employees time. We're trying to save money for the end client.
I mean, it sounds to me like, based on the description you gave, that's not necessarily pharma based. I mean, so let me ask you this. I mean, usually pharma is the last to pick up on new technology simply because that's what we are. We're embedded in, we're heavily regulated, bottom line, we got to go slow. So, I mean, what's going on out there that you guys see that maybe, we got to wake up and take a look?
Well, I mean, I think that's quite a bit of it. Is obviously the augmented reality is making a huge play, and then obviously just going leveraging technology wherever you can. I mean, I'll go into a facility and give you an example. And I won't name the facility, but you go in there and they're going through and they're basically starting to load product in the bags and they're on the tray, and they're going through a paper manual and a binder, going through and and she's just calling out basically, okay, this step, step 2, step 3, step 4, where really you could be a paperless system, right? You could have that all loaded in, for instance, Google Glass is very small, just basically appears like a little lens on your glasses, and you could have all your documentation right there at any given time. Not only that, but you can actually have hand instructions or whatever it may be. So I think there's a lot of advantages that could be taken in, but obviously you have to look at each process you do and then see how that applies to your process.
What has been your experience? I mean, for example, these things sound like they'd be ideal for either a contained area, a highly potent area, or high solvent area. I mean,
yeah, so I guess the example I was going to give goes back to something that you showed me, was that prototype that you guys are working on. It was in the semiconductor industry. Yeah. I think that's a really cool example of something that could be eventually making its way into the pharmaceutical industry.
It's an example. I'm sorry, I missed the example.
It was basically kind of the example I gave as far as, for instance, we going into a clean room and you have a chem cabinet dispensing unit. And typical maintenance would require, or typical checking would require you to open that panel, getting dressed in the full PPE to make sure that obviously no splashes, nothing gets on you as far as the operator goes. But being able to pull up the stats of that piece of equipment by just looking at the QR code on the piece of equipment with your glasses. The glasses are linked to the Wi-Fi. It'll pull down the stats of that piece of equipment. And then also, what it allows you to do is look inside the piece of equipment virtually if you want to see, okay, I want to see what the volume level is for that. For particular, you might have two 55-gallon drums with chemical in it. You can get the volume of that without even opening up the cabinet. So that's the part of, or actuating a valve from outside the unit by just voice command.
Mm-hmm.
So, and then if you have, like Yvonne said, if you have trouble, you call back to the control room. They log into the glasses via Wi-Fi and either help you along, or they can even take control of it right from there, from their remote side. So that's something that, for instance, our counterparts in Germany for Kinetics are working on doing that type of control within our facilities management. So overseas, Kinetics does a lot of facility management. And for our guys, that's what we're leveraging as far as trying to operate this equipment, keep them safe, because safety is our number one priority,
Right.
regardless what industry you're in.
Okay, so I'm looking, the thing I always ran into when we were trying to do something new was always I had to, did I think through everything? To me, I'm enamored with using it, but what do I need to think through as a deciding factor so I could sell it within the cross-functional network of my company? In other words, obviously we're talking about something that fits the process guy and the engineer in a niche, but he's got to get buy-in from IT and QA and all. So what are some of the deciding factors I got to be, help me make the argument, or us the argument?
Yeah, I think that's a good point. I think the one thing is in implementing any of this, you need to have leadership on board at the beginning, and have them behind whatever you're going to be doing, and consider what the value is going to be for your company. Like I said, some things may make more sense for some companies versus other Industry 4.0 aspects. So I think you really need to consider the cost, what's the value going to be, and how's it going to affect the culture of the people and how they work.
Right, but I think the other question is, again, you got to remember, it depends on what it's going to do. If it gets near a product or it's about a product, it's all that, CFR 11 and all this other stuff comes into play. It's about compliance, it's about CGMP, it's about GLP. How do I sell that? What's been your experience there? You understand, when we're in a regulated area, then it becomes even more complicated. So can you help me out with that one?
I was just going to say real quick, I know the one thing that this does impact IT, and it does impact quality, and you definitely need to get those groups on board with anything like this, because everybody has to be on board with this, because it affects all of those groups.
I would say it's basically just adapting to the technology, right? Technology is ever evolving. I know last year CRB had a panel up here, and they talked about the potential of AR and the potential of VR, and we're here a year later, and it's already actually in use, right? So the company, I think, just has to be devoted and committed to moving forward with technology. It's kind of, I guess, part of my position within Kinetics is to look at technology and how do we leverage that to run the company, and how does it fit within our company. So obviously you're going to have somebody like that within, whatever company it may be. You have to have somebody dedicated looking at advantages of that technology and how does it play with the regulation. Can we do it? What are the restrictions as far as an IT aspect? What are the restrictions as far as your infrastructure? Do you have Wi-Fi everywhere that you can utilize this type of technology for? What is it going to eliminate, right? And that's where your ROI comes in, is what are you going to save by this, right? Well, for us, give you an example, laser scanning. Laser scanning has been around for a couple of years, getting into these facilities. Our ROI is that we don't have to send somebody on a plane. We can come out, laser scan a facility within a week, take that information back to our hub, our design hub, and not have to fly out again, because we have everything we need to be able to design that facility. Or make any modifications to an existing facility. I think that's where that ROI comes in. So you just have to figure out what you're saving, and then obviously you have to know how to sell it to your organization, right? What's your ROI? What are you truly, at the end of the day, going to improve? Because if you have no improvement and you have no ROI, what's really the benefit of doing it?
Gotcha. But you got to remember, we're dealing with an industry that to put a process logic controller in was considered, building the Starship Enterprise. I mean, that's the kind of industry we're in. I mean, we've progressed, but at the same token, it's against that backdrop. Is it locked down? Is it not touching? Is it, and that's not always in the control of the tech guys. I mean, so you got to help me talk to the guy in IT, but more importantly, you got to help me talk to the guy in quality to give him, I'm okay with this. It's not going to create a problem. I mean, what I'm trying to say is, there's companies that say, okay, everything I'm going to do that is cool or the technology I'm trying to push forward, they isolate that into development, nothing to do with GMP. Yeah. You know what I mean? So, I mean, that's how not exotic, that's how extreme it gets. So, can you help guys talk through this? I mean, that's key.
Yeah, it's really just I think it's a shift in how we think, because you can continue to do things the way you normally do, or you can try to move forward, obviously. And like you said, the biopharm industry is very rigid. It's very structured and very heavily regulated, right? So that makes people afraid of change, because any type of change you typically do, invokes some type of response.
Right.
Give you an example. Validated isometrics, right, that are used for your process systems, and keeping those up to date and having those to this date. As much as we can go to the grocery store and we can sign our ATM or our credit card statement, right, virtually on a keypad. We can electronically file our taxes with the IRS. We can request every type of document in the world electronically. However, the industry is stuck on, they want wet signatures and handwritten documentation on the back of an isometric. And really, there's no regulation that requires it. They just require that you capture the information. But
right.
It's a mindset. People want that wet signature. They want that, for some reason, that's a security blanket to them.
Well, we want to thank you too. Thank you very much. Thank you, guys.
Thank you.
You want to stick around. Actually, our next present is going to be on adding intelligence to legacy aspects. And they'll be talking about artificial intelligence. Okay? And Matt's